Welcome to next session on microprocessor architecture. As I already stated that the entire purpose of these lectures is to make you completely aware about the functioning of microprocessor. Even though actual entire digital circuit inside and its fabrication is not possible, but at a block schematic level we shall cover up to such an extent that few of you who might be interested to pursue the things further, maybe especially those who are in electrical engineering, they may feel that they need this, then they should be able to design their own processor. That is, we must at a substantial finer level in the inside of microprocessor block schematic level, we must be able to understand the functioning of the microprocessor. Remember that in today's world, everything is now the computer, which was considered to be a big, very big device few decades back then, a bigger one now, that the computing power has come into a very small chip. Even your mobile phone is having that small chip, that is microprocessor. Then ultimately, right now, our Arduino till the what we can say the processor chip in the supercomputer, all are microprocessors. So microprocessors function in a very peculiar manner. There is an what we will not be able to cover in the entire syllabus, because that is not expected at all, is an actual digital gate circuit of mine. To be very precise, that also see, since that is manufactured by human being, it must be known to somebody, but that is too big, so we don't go for that those micro details. But what a microprocessor means, a schematic level. So last time we studied an instruction set also. Today, even though we are 80-85 focused, we are not 80-85 biased. We are 80-85 focused, but not 80-85 biased. So a microprocessor chip, we model the lines, all these things like 80-85, so that it is somewhat, there is no, see, to teach you, some example must be given, and there is no need to give abstract example of something which is not existing. So we take 85, that is now an obsolete processor. Actually 85 is not used in practice, but still it is a very not because that it is my liking, but otherwise also it is a wonderful architecture, because now anybody can understand what we can say microprocessor, anybody can do a microprocessor programming. But those days, in late 60s, when it was introduced first, it was considered to be a very good architecture, and which became very quickly famous throughout the world. There was an era where 8085 means maybe not more than a decade, because its upper versions came, but at least one decade it governed the entire, what we can say, atomization in the world. Abroad in 80s, in what we can say 70s, and in India in 80s and early 90s. So we try to understand its functioning from within. So as von Neumann has predicted in 1940s that there would be a CPU which will access the external world, that is memory, using address bus, data bus and control bus, and obviously a reset, it is reset bar we take as it is, and clock. Now how will you design? What we try to cover, we cover few instructions. Few instructions I told, because we have to start somewhere. Just like in 11th, a teacher starts with quad coordinate geometry by putting a point even though it is not a point. Therefore, everything abstract is not possible, so we started somewhere. But now I can say, we can proceed further, is that means what I am trying to cover. Remember, you don't much focus on evaluation, examination, all these things. That is not the purpose of our education. On a mass scale, that evaluation is needed, so we go for that. In the last year, you appeared for CET because based on that admission was there. But now onwards, whatever competency you get is important. There may be some people who are more competent but could not get good marks in evaluation on mass scale, and vice versa. But what I propose is that you be good and fair at exam, but must be very much focused on developing competency. So I think that the purpose, see, you may find that I am taking somewhat odd approach than conventional approach which you might have come across. But the purpose is that in today's world, telling something which is available elsewhere, what is my exclusiveness? What is my purpose? The purpose is lost. If everything is available elsewhere, then why should I repeat? So I don't repeat that. So what I try to make you aware, I try to take you to the journey where you will be able to design a microprocessor. So what microprocessor, how it works is to be very rigorously analyzed. So what is very clear, that microprocessor is a device which is competent enough, which has got having an address lines, data lines, and control line. It's D7 to D0. It's D7. You're right. D7 to D0. Right. Okay. So address lines, data lines, and control lines. So microprocessor with respect to external world can undergo a read cycle or write cycle. Now, how is the design instruction set? All this, and then few of you who may be somewhat smarter will feel that at initial stage some repetition is there, but that is also required because you are not a machine. Students are not a machine. So when they listen something after some time, it is not that they can resume where they have left. So some kind of primer is needed, and that is obvious in a human system. So what microprocessor can do is very clear. Then what is our target? Microprocessor should be able to read something from external world. Based on that, some kind of complex evaluation, and then it should output something on other lines there. So ultimately what we have got, this is the external world, which includes memory locations which are read only, read write, and input locations and output locations. So there are few input locations, we say 8, let it be 8, and few output locations. So what means there are 8 inputs and 8 outputs. So with respect, if you say with respect to this chip, this is external, but with respect to me, what I am having, when I as a user look at microprocessor, when I as a user look towards microprocessor, what is with me? Means, suppose that, let us imagine, I claimed, I am taking this example just for fun, that I am a great teacher in the world. Let us say, I claim so. But I am not taking lectures. So you will say, oh, you may be great, but what is the use for us? So I may be occasionally meeting, that's also for you. What is me? Only the occasional meetings. What is going inside me? I may be a great philosopher next to what we can say Einstein. And just I come in the class, start thinking something, and do like this, and utter few words, ask few questions, listen that, then utter few words and go. So for you, what means? Only you are able to talk something and I answer that, you are able to listen something. So you are only that. For you, I am only that. So for me, for user, what is microprocessor? For a user, microprocessor means the CPU and here the memory, read-only memory, that something is put read-write memory. So for me, only the means I can supply something to microprocessor based on these pins and microprocessor will supply its result to me on these pins. So this I can drive relay current and so on. So microprocessor is a system which is having 8 inputs. Let us say 8. It can get extended. Some more ports you can add. So few input lines and few output lines. Then we will say why it is microprocessor required. Can't I design a digital circuit? Yes, you can certainly design a digital circuit, but that digital circuit you design for one application. Suppose the application changes, you have to redesign it. What is microprocessor? Microprocessor is the same system, only when you change the program. Means microprocessor provides you. Means just now today you are having various apps on your mobile. So what these apps do? These apps, when you use this particular app, other particular apps, you get whatever you want. Means it is very easy and simple for you to get new app and get the things done. Like that, it is not exact parallel example, but just to give you an idea. So a different program means for me, this entire system, when a different program is put, this becomes the way in which Microsoft takes inputs, treats them and results or generates outputs changes when the program changes, right? So what Microsoft can do, it is that way. Now static or dynamic also depends upon the way with which you are looking at. So to be very precise, it provides you a as a whole, this micro CPU and its associated program provide you a flexible digital circuit which works as you like. So you are means, remember, everything microprocessor is not an exclusive entity. When it would have an exclusive entity, if microprocessor, something which can be done with a microprocessor cannot be done without a microprocessor. In that case, microprocessor is exclusive. But in that context, microprocessor is not exclusive. You can design a separate circuit for something which you want to do. But microprocessor provides microprocessor means it is just a computer. Without computer, can't you calculate? You can. But the flexibility and ease of operation which computer performs in general and microprocessor performs is phenomenal, is extremely large. That microprocessor has revolutionized the world. That wheel, then current, electricity and IC engine together at the same time, and then microprocessor has changed the entire way. Means prior to microprocessor means because there is not a single thing which was not possible to be done when microprocessor was not there. Everything could have been done, but the effort means what teacher should be. Without teacher also students can learn, but teacher should make it so easy that a student means a book, a student reading on his own, and a book which student reads after teacher tells what to read, how to read. That should make a change. So that microprocessor does. So we start now. So microprocessor, what we want? Must be able to read, must be able to write. That is very clear. Then some kind of processing. Add, what processing it can do? Very minimal. Add, sub. Means add, sub, or, and some complement. Sometimes rotate, means multiplication. Sometimes rotate. That binary arithmetic, we will not go into details now, that is not required. Few decades back, knowing binary arithmetic was taking a semester. So some means, what are the instructions? To be very clear, the instructions are classified as number 1, which we discussed, data transfer, data processing. Processing includes all, that is arithmetic logic, and control transfer. That is very important. That what is means what an instruction is received by microprocessor from outside. An instruction is received by microprocessor from outside. So it reads the memory locations. So since the data bus width is 8-bit, 1 byte is a, what we can say, unit of almost all things in digital logic. Why 8? Why 8? There is no unique answer. 4 is too small, 32 is too big, 16, there are 16-bit processors, but still somehow it starts with 8, and 8, that is one entity of a byte, is there, and that one entity of the byte has continued for decades together. So 1 byte. So what microprocessor should do is that if you are the instruction set designers, then what is an instruction? One of these 3 means that should, so inside microprocessor, as we have said, that there is, I have drawn it above, one important register called as instruction register. So the instruction means you read timetable of examination. Based on the symbols which you read, you understand everything. Like that, what microprocessor does? After reset, the main thing again, after reset, microprocessor is having one program counter which we already discussed. That reset makes that program counter 0. The program counter is used to read the instructions from memory. So program counter becomes 0 and microprocessor performs a memory read cycle that is called as an instruction fetch cycle or fetch cycle or sometimes an opcode fetch cycle. So what microprocessor does is after reset, when microprocessor starts functioning, just like let us say when the baby gets born, baby starts crying, like that. What microprocessor does after reset? After reset, microprocessor reads the reads the location 0. Microprocessor reads location 0 means microprocessor puts address 0 on address lines. Means suppose that I am taking an attendance in what we can say a Google Classroom or Meet or Microsoft Teams, and I say call the roll number 5, and somebody will say yes sir. Means for me, I called roll number 5, I got yes sir, I say that roll number 5 is present. The same is the logic. microprocessor outputs 0000 on address lines, activates read bar. It is expected that an arrangement of a proper decoder, multiple memory locations are there, and that will put something on data bus. So, as a result of the first read cycle after reset, which is now 4-page cycle, microprocessor receives one 8-bit value. One 8-bit value is having, one 8-bit value, one byte is having 256 combinations. So they are 00H to FFH hex, or I can write all zeros. That is one way to write. Or, because this is important, this, what I again repeat is that many may say that I am repetitive, but I want to bombard you in such a manner that tattoo you must be knowing. ज्याला मराठीमध्ये गोंधणे म्हणतात, तुमच्या घरी विचारा की इतकं प्रभावी ते गोंधणे किंवा टॅचू असतो, एम्बॉसिंग, की सर्जरी शिवाय काढता येणार नाही. यू कॅन नॉट फॉरगेट दिस फॉर युअर लाईफ टाइम. सो what microprocessor will receive, it will receive a number, an A or a combination of 8 bits, which will be one out of these 256. So then it is very simple how the instruction register is designed. The instruction register inside microprocessor is designed. Now how that is actually implemented, it will require a huge number of gates that we can't discuss. Means that is it's not that I am skipping, but that is not required also, that is not possible also. So means even why so, even at the medical field, in a medical college, what exactly makes the heart to function cannot be explained by any doctor. How? Why heart functions, that the person is lively? Why? Nobody can say. Just like that, we don't need to go into details of how exactly it is implemented using logic gates. So what? But we must what I stress is that when I say something which we did not know, so you may believe me and ignore that. But what? At the same time, what I say, this means I tell you to assume something so that there is no need for you to know anything out of that. But at the same time, I tell that this you should understand fully, means you must understand everything out of that. Nothing of few things and everything of few other things. That is very important. So microprocessor receives one 8-bit value, and instruction register understands that, and then it asks the internal microprocessor, that is what is the inside microprocessor. There are few temporary locations, including an ALU. There are few temporary locations. A, that is flag, B, C, D, E, H, L, and there is one more, stack pointer H, stack pointer L, stack pointer. I will explain all these things, what is needed and so that. And then there is one temporary not seen. So WZ, I put that not accessible to the user. There is some temporary register. This is something with which the microprocessor can function. Then when this goes to instruction register, what microprocessor can do? The instruction can be for either of these: data transfer data from one location to other location, data processing, control transfer. Then it is up to you to decide how many instructions you want. How means it is, we will say that if you decide to earn for yourself, you have come here to make your livelihood easier. You decide to earn for yourself. Then if you go for money, It is just like there is a story told that the king tells a person says, no sir, I am landless farmer and I need land. Then the king is very generous. He tells, yes, you start from here. This is the width is say 100-meter width, and length is till the sunset, wherever you can run, that much is the length is your farm. Then he starts running fast and fast to get more and dies just before the sunset. So what is sufficient is also a judicial disagreement. Like that, how many instructions we must think of. So that is also means there is no need after some stage, there is no need, there is no use of resources. So to have very large number of instructions is also not useful. To have very small is, you will find it difficult to work with. So you need to optimize the number of instructions. So suppose if that let us say, just I am telling you, suppose that I want, somehow say I want that total number of instructions should be 2000. Total number of instructions should be 2000. And if total number of instructions are to be 2000, how will you sequence? How will you number them? Which code means means it's a table. When you see something, suppose that you see a symbol 3. Is it 3? No. It is, you were told, you were taught in your childhood that this means 3. So in the table which resides in your brain, this is accessing a particular entry in your brain. Like that, a combination of all zeros, when microprocessor receives all on this as response to memory read cycle from address 0 to be fetched as an opcode, as it's a fetch cycle, something is received. What is that received is treated as an instruction. So if I want that my microprocessor should have 2000 instructions, if I want that it should have 2000 instructions, then what will happen? If I want it to have 2000 instructions, in that case, whether if only I decide that the one byte I receive will tell me which instruction is. If number of instructions are less than 256, then I will understand the instruction in the first byte. But if number of instructions are more than what is required, that whether I will be able to understand the instruction completely, whether one byte would be able to sufficiently code my instruction set. No, sometimes I will be required to read next byte. Then what I can have? Some frequently required instructions I will encode using one byte. So 0, 0, there is hex, all zeros will mean something. 0, 1 will mean some other thing. 0, 2, hex I am talking about. 0, 0, all zeros, 7, 0 and 1, then 6 zeros, 1 0, like that. So each combination will mean something. Each combination will mean something. Then how I should design the instruction set is that what instructions I want. So let us talk about data transfer instructions. So in data transfer instructions, there has to be a source and there has to be a destination. There has to be a source and there has to be a destination. So in data transfer instructions, when source and destinations are there, so source and destination both can be inside microprocessor. Source and destination both can be inside microprocessor. Why? Because for some kind of further processing, you need to store, just like you have a scratch pad, you are doing some calculations, you store something at temporary storage which you are required to use later. So like that, some kind of scratch pad, some kind of registers you want to use. So both source and destination can be inside microprocessor. That is required for some kind of scratch pad like storage. But major application should be the location should be in data transfer, either source or destination. Either of them is one of them is inside, one of them is outside. Both outside normally we avoid, that we right now not take up. So in general, data transfer instructions, so I will explain you how the instruction set is designed. Data transfer instructions contain source and destination. Both inside one outside, one inside. Okay. So if both are inside, then inside there how many registers are there? Inside microprocessor, number of registers are 1, 2, 3, 4, 5, 6, 7. This 8 times you can say 10, 11 and 12. So you need to give them, so you need to specify which source and which destination. For that you need some code. Then what you can do, when I am looking at the instruction set, there are 8 bits. So based on these 8 bits, I will try to encode few instructions. If internal data transfer instruction from register to register, I can have, means that I will call as move B comma, so say for example I am giving, move B comma C means there is a convention. This is source and this is destination. This instruction moves data from register C to register B. So in general there are how many registers? 1, 2, 3, 4, 5, 6, 7. These are addressed separately. These are used separately. So there are 7 instructions. So in general, 7 register. So in general, there would be, in general, we are talking about we are just talking about how the instruction set is designed. It's a very fundamental piece of work which we are doing, which will be extremely useful for you in your future career. If you ever come across the microprocessor, electrical engineering students will certainly come across mechanical and civil. Now that since everything is now AI based, so for AI you need a microprocessor, so that is also required. So there are total 49 instructions. There are total 49 instructions. A 1, 2, 3, 4, 5, 6, 7. Why 49? Somehow means you will find that there is some instruction move, if you design move B comma B, that is redundant. So but somehow if you go for further hardwiring of actual implementation, then to make it easy, you will find that these instructions are also there. just like no operation instruction, dummy instructions, but in the logic when the instruction was designed, it was like this. 2 bits are having, out of 8 bit instruction, first two bits are something fixed, and then 1, 2, 3, 4, 5, 6, 7. So you use these 3 bits to encode one register, that is destination, these 3 bits to encode source, and these 2 are fixed. So total 49 instructions. There are few are vested. So 49 data transfer instructions are there. Out of 256 instructions, you use 49 for that. Then 2 instructions we saw last time in the first lecture. That is, one of the things is outside. One of the things is outside. Means either source or destination is outside and one is inside. Remaining is inside. And for that, this accumulator is equipped with some kind of a special purpose. Many operations are possible only with accumulator. That is the that time design limitation. Now you will find that there are more generic microprocessors. So something from some location outside here or something from here to here. So those instructions are called as load and store. Load, which we saw last time, and store. And what? A. Why A? Because it is accumulator. From where or to where? External. But in that case now, loading a accumulator from outside. From outside means a question will come where. So that needs to be specified. So that instruction means loading accumulator from external world. Means there can be 65,536 instructions. Because you can load from any of the external address. So that instruction is a 3-byte instruction. So the first means the instruction is like this. Number 1 byte instruction. When that instruction, listen very carefully, in each instruction microprocessor performs an opcode fetch. So first fetch cycle is always there. Fetch cycle. After the now listen very carefully. After the instruction is fetched, if the instruction is register movement, okay, it is fetched completely. Everything is known in the first byte. So fetching is over. Sometimes if the instruction is LDA, then you need, since the instruction is load accumulator, from where? From a 16-bit value which is part of the instruction. So it is 3-byte instruction. LDA and address 16 is the harmonics. Nowadays that is not taught. Assembly language also not required because we are having cross compilers. You can write program in C or Python and directly port in on Arduino. Or you can write a program in, there is IDE, Integrated Development Environment. You can just write like C and code, but you must know how it works. So fetch, opcode fetch for LDA, and this address is to be read Y2 because address is 16-bit and in one cycle you can read 8 bits. So microprocessor 8085, now this is 3-byte. There are some 2-byte instructions also, that also we will go through. So microprocessor there are total maximum 3-byte instruction. Microprocessor performs complete reading of instruction in either 1, 2 or 3 machine cycles. In either 3 in performing one memory read or one memory write is done in 3 clock cycles. 3 clock cycle is 1 machine cycle. So microprocessor performs one complete instruction read in either 1, 2 or 3 machine cycles. And how it knows? When the first byte is read, the instruction register knows which instruction it is, and depending upon which instruction it is, if the instruction is corresponding to moves B, C, then instruction register, suppose that there is a master servant example. Then in master servant example, there are some instructions. Say for example, master tells, let us take simple instruction. Master tells the servant, now sleep. So, okay, my job is over, you sleep. So, when the instruction to sleep is given, whether anything is further needed to tell, no, we will sleep. Then master tells the servant, go. Whether sleep is a single word which completes the meaning, whereas go, whether the meaning is completed, no, where to go, right? So like that instructions are there. And then when the first byte is read, microprocessor comes to know that it is how many byte instruction. So when the first byte of code is fetched, microprocessor knows the length of the instruction, and then if it is 1 byte, the instruction is completely understood, it executes that. If it is 2 byte or 3 byte, it reads further bytes. So in either 1, 2 or 3 machine cycles, microprocessor performs a complete instruction read. Then it is a microprocessor, it is a servant, it is supposed to act what is told, so instruction is read. So various instructions are given in Google Classroom. For what purpose they are given? To be followed, but we find it hardly they get followed. But that is not a practice with microprocessor. So microprocessor performs instruction read. So in these 3 machine cycles, what microprocessor has done? It has performed instruction read. This is the opcode, these are the operands. Now what must follow? Instruction is given for performance. So microprocessor has to perform the task assigned. It has to execute the instruction. So it will execute the instruction. Then instruction execution, now whether instruction execution, suppose if the instruction is some movement inside, some calculation inside, then for that everything will happen inside, so that will happen instantly. That everything, that if instruction is move B, C, it is ready is 1 byte and instantly gets executed. Why? Because everything is inside microprocessor. But LDA, load accumulator from, if the instruction is like this, LDA FF F8 means from the address FFF8 where this input port may be mapped. So LDA FFF8 means the instruction tells the microprocessor to transfer the contents of external location FFF8 into accumulator. So how this to be executed? In this instruction, the content to be transferred outside, and where to be transferred is inside. Therefore, this instruction will require 1 more cycle. So the idea which is very clear is that number of machine cycles needed for the instruction is length of the instruction plus number of external references required. So here the next cycle will be, so in the first 3 bytes it has read the instruction, in the next byte it will read actually the location. So in the 4th machine cycle it will execute that instruction. When that is over, it will go to next instruction. Then what other instructions can be now? This is called as image. Now that 3 decades back, the addressing modes of microprocessor itself was a very huge topic. Now it is no longer. No, means it's there, but it's no longer that much important. So here the load instruction microprocessor wants to bring data from outside to inside, and accumulate is the by default location inside here, and the address from where I should get is given where as a part of instruction. So it is called as direct addressing mode. Means the address of the operand in the memory is given as a part of is directly part of instruction. There is one more called as indirect addressing mode, and out of these various registers, some registers are used for some purpose. That is, H and L register pair is used for addressing, indirect addressing. That is, in the instruction set, just like move B, C, there is one instruction, move B, M. Move B, M. What that is? M is not a register, but M is used to represent an external memory location. Which memory location? So move B. So if you are able to understand this, you will know how to think. Means what I want to inculcate. See, remember that working of Arduino, now you just give on Google Arduino, everything in the world will be available to you. My purpose of these lectures is not to repeat that. So once you know, move the instruction move B, M. What is the source? What is the destination? B. What is the source? M. There is no M register. So what is M? In the assembly language, this M is an external location, but when I say external, address is needed which pointed by. In C programming, the concept of pointer is there, which you must have actually nowadays. When in early 90s, people used to work exhausted on C programming. That time, working on pointers means there were few people who could do simple C programming, but super experts were needed to work on pointers. So you may be knowing that Yashwant Kanekar has written simple books. Let us see. Like that, he has written a book, Pointers in C. So pointing, that is addressing a variable. So move B, M is move to B the data from memory location M pointed by HL pair. Or move, let us use A, because I remember the opcode. Move A, M. The opcode is 7E. So the instruction is move A, M. Opcode is 7E. So 7E opcode tells 885 tells the microprocessor to bring the data from the external memory location M into A, and which location? Whose address is given in HL pair. So address is not to be given separately. It is a single byte instruction. Move A, is single byte instruction. Microprocessor reads that instruction. how will it execute? How will it execute? For the execution it will require in the next machine cycle. Last time I said that in each machine cycle some register pair gives address. If it is write cycle, some register gives data. If it is read cycle, some register pair gives address and data goes to some other register. So in the next machine cycle, register pair HL will give the address. There will be memory read cycle and data will go to accumulator. Like that, there is another instruction, move M, E. Move M, E. That is 77. So what that will do? Same exactly reverse, that is whatever is in the accumulator, so is to be stored into memory location. Which memory location is given by HL pair. Again, single byte instruction requires 2 machine cycles to execute. So this is move. Then data processing instructions we can talk about. So data processing instructions are add. In this accumulator is add instruction gives you only one 8-bit value, add B. Add B is what? A is equal to A plus B and carry flag. Like that you can have add C. Like that you can have add M. So again a 1 byte external memory location given by HL pair will come inside, that will get added to carry flag and A will be A plus that M. What is M? That is pointed by HL. So you can have add. Then like that, now there is no point in going into the details of various instructions. Add you can have, sub you can have, and you can have, or you can have, XOR you can have. Like that add, if you want to have 16 addition, then it is add with carry. It is carry flag and A is equal to, in simple add, only A and B are added and carry flag reflects the addition, whereas in add with carry flag and A gets assigned to A plus B plus old carry flag. So if you are having a multiple byte addition, then it is A plus B plus old carry. Where is add with carry, if the instruction add with carry B. So similarly in subtraction, 2's complement arithmetic and all that, it is subtract with borrow, SBB. So like that is, there are various, what we can say, data processing instructions. And then control transfer. What